Hey guys, my name is Sancy Horman, and I decided to talk about, I believe it's prompt 3 about Bryce Canyon National Park. The prompt says, describe the formation of Bryce Canyon National Park, and then discuss the deposition of the Claren Formation and how its properties, combined with weathering and erosion, has helped shape the unique landscape that we see today. So let's dive into Bryce Canyon National Park. To start, the formation of Bryce Canyon took place over 60 million years ago during the Cretaceous time frame or period. There are many different effects and processes that took place, all coupled together, created obviously Bryce Canyon and the park that we see today. So the things that take in place, I guess, or you have to take into consideration is differential erosion, water, ice, gravity, and frost wedging. Differential erosion, by definition, states that it is erosion that occurs at irregular or varying rates caused by the differences in the resistance and hardness of surface materials. So basically it talks about just the different materials and rock types that make up this area and how those rock types respond to erosion and what's going on around it. And so if we combined differential erosion with water, ice, and gravity, that is what has created the formations that Bryce Canyon is so famous for today. And then as Bryce Canyon was forming, water would actually get into the breaks and joints of the rocks, and that water would start to flow through the rocks and may freeze and then thaw, which again widens the cracks, which is the frost wedging that we see. And over time, these small joints and breaks in the rocks created these giant gullies and rivers and these slot canyons that we are so fortunate to be able to see today. So the second part of the discussion here was the deposition of the Claren Formation and how all of its properties have coupled into shaping the unique landscape that we have today. So there are a couple different rock types that make up the Claren Formation, and that is limestone, siltstone, dolomite, and mudstone. Each of these rock types erode at different rates, which causes the unique shapes that we see today. So the protective parts of these spires and hoodoos that we get to see are made of very hard types of rocks. And this includes the limestone, siltstone, and dolomite. These rocks are eroded mainly by frost. So again, that'd be like the frost wedging and whatnot. While on the other hand, the mudstone is the softer material and the softer rock that's found in Bryce. The mudstone actually acts as a protective like stucco on the outside of these spires. And as it rains, the mudstone will kind of drip down these spires, and then as it dries, it hardens. And so there's no wind erosion that takes place during this, but rather when it rains, that's when the stucco on the mud on these spires replenishes itself and keeps the formations strong and going. So again, like I said, that rain and water and those kind of effects is what mainly happens in Bryce Canyon and what causes the formation that we get to see today. I hope you enjoyed this. Thank you so much. My sources were brycecanyon.com from the National Parks page, and then our Geology of National Parks book, Chapter 3. So thank you.